Hello. Today we're going to look at functions. And what a function is a special relation. Now remember, with relations, we know that they are a set of ordered pairs, so it can be something like this. We also put those in a table. And we also did those as a graph. 2, 3, 3, 2, 1, 4. So we looked at a relation, and we looked at tables, a set, and we also looked at a graph. Well, functions are a special relation. There is a special rule for functions that has to do with that relation. So what is it? Well, a function, what is a function? It's a relation where every input, which is our x values, gives a unique output, which is our y values. In other words, there are no repeated inputs, no repeated x coordinates. So let's look at this first example. Now what we're going to focus on is our x coordinates. 2 is the x coordinate in that ordered pair. 3 is the x coordinate in that ordered pair. 7 is the x coordinate in that ordered pair, and -3. Well, all 4 of those numbers are different. They are unique. So since all of the x values or input values are unique, this is a function. Here's another example. Again, we're going to look at our x values, not our y values. They can be the same all day long. It's our x values that have to be unique. So the x values here are 3, 4, and -3. But note that all our y values are 6. But that is not what determines if the relation is a function. The relation is a function if the x coordinates are all unique, not the y. So the x coordinates are all unique, so that is also a function. What does it look like on a graph? Well, we do a test which is called the vertical line test. So remember that this is the x-axis. So if I go to x equals -2 and I draw a line up and down it, I only cross that graph once. At -1 on the x-axis, and I go up and down the through the x-axis, it also crosses this graph only once. That is showing that it has unique x values. This also, everywhere I go along this graph, if I draw lines down through the x-axis, so I'm drawing the lines through the x-axis, and they only cross once, that means each x has only one unique value. So this is a function because each x value only has one unique value. Let's look at this one. So at 5 here, draw a line down through there. It crossed that line one time. It crossed it once at 6. It only crosses it once. As I go down through here and go through, draw lines through the x-axis, that's why it's called the vertical line test, each x value only has one unique value on the graph. So yes, this is a function. Now I'm going to show you what I mean by what if we take a line, and I'm going to go to -2 right here, and I'm going to draw a line down through there. We crossed the graph, the picture of the graph, twice. That means that x value doesn't have one unique value. It has more than one value. -2 can be paired with this up with the this up here and with this down here. We want x to only have one unique value. So the 2 crosses it twice, and if you went ahead, like here at 0, it's going to cross it twice. Doesn't matter, it could cross it 14 times. As long as for it to be a function, it may only cross the graph once. These vertical lines that are going through the x-axis can only go across the graph once in order for it to be a function. So this one is not a function. So remember, a function has unique or different x values. The x value cannot be used twice. So this 2 matches with this number up here and this number down here. So that 2 has 2 matches. And so the x value could only have one and only one match. The x values have to be unique. Not talking about y values, talking about x values. This right here is called function notation. Y is our output and x is our input. And that's what a function's kind of sort of like. It's like a machine. You put something in and you get something back out. This way this function notation works, y is the number we're going to get out of the machine. F is the name of the machine or the name of the function. And X is what we're putting into the machine. So F is just the name of the machine. Let's do that again. Y is your output. F is the name of the function. X is what you're putting into the function. So again, we want to have unique values for X. We want to input that into the function and get an output. X is our inputs, Y values are outputs. So when we look at an ordered pair, like we've been looking at in our other lesson, this is my input, this is my output. So I'm inputting an X and getting out a Y. And I'm never putting in the same 2 X's and getting a value for it. I can't have put in a 2 and get out a 3 and put in a 2 and get out a 9. That's not a function. When I put in a 2, I only can get one value out. It won't give me 2 different values. So what we're going to be doing is we have here an equation, y equals 2x minus 3. And the reason we have an x and a y is we are looking at the ordered pairs that we can place on a graph. And this is kind of like our function. This is our function rule. So our function rule here is 2x minus 3. Y is one way to write this. And then f of x is how you say that. F of x, the function where you put an x in it. So it's a function that you put an x into. So if we wanted to name our function something else, we could. And this over here is our function rule. So here we have our input values. So what we are doing is we're inputting a number for the x. So all I'm doing is taking the -1 and I'm going to change the x into a -1. Now we've talked about this before, but that 2 and x together is multiplication. So I can put this in a calculator. 2 times -1 minus 3. When you put that into the calculator, your output is -5. Now we're going to input a 0. So we're going to say 2 times the 0 minus the 3. Again, you can use your calculator to get the value out. The value is -3. We're going to input a 1. So that's 2 times 1 minus 3. Again, I can use a calculator. 2 times 1, subtract 3 is -1. This 2, I'm going to input that value. It's 2 times 2 minus 3. And that is 1. Then we're going to input the 3. 2 times 3 minus 1, and that is 5. So now what I have is I have my inputs and my outputs. So when I put in the -1, I got out a -5. So if I wanted to come over here to my graph, that would put, it's going to be hard because it's a little graph for me. There'd be a dot right there at -1, -5. Then I would have a dot at 0, -3. And then I would have a dot at 1, -1. A dot at 2, 1. And a dot at 3, 5. Oops, I messed up. Oh, that should be a 3 right there. So I messed that up. Let's go back and fix it. Going to erase this. Okay, 2 times 3 minus 3 is 3. So please fix that. So when I input a 3, I get out a 3. So these can actually be ordered pairs. And in my graph here, it's really small, so it's real hard to get that detailed for me. So hopefully with your pencil you can do better. But these are my inputs and outputs, so I could write these as ordered pairs. When I put -1 in, I got out -5. When I put 0 in, I got out -3. So you can write out the ordered pairs for these so that you can graph the ordered pairs on a line, on a graph. And they will form a line because we are talking about a function that graphs a line. It's called a linear function. And we're going to be focusing on those a lot in this section. So here we got another one. Here is our function rule. X is our input. Y is our output. If we write it with function notation, the function's name is f and the input value is x. So I'm going to do that here. I have -3. I'm going to put a -2 in place of the x plus the 4. -3 times -2 is 6, and 6 plus 4 is 10. -3 times 0 plus 4. -3 times 0 is 0 plus 4 is 4. Again, you can use your calculator. But the key here is to understand that your input value replaces the x. Then you do the math to get your output value. So that's -6, that's -2. Then I'm going to put the value 3 as my input. Using a calculator, -3 times 3 is -9, plus 4 is -5. Then we have a 4, so we're going to have -3 times 4 plus 4. That's -12 plus 4, or -8. Again, because this graph is so tiny, it's going to be hard for me to get these on here, but hopefully you can. So -210. Let me erase that because it messed up. Okay, so let's do -210. See, it's hard for my little stylus even to get on there, but there it is, somewhere right there. 0, 4. Right there. 2, -2. I gotta remember not to use a graph this small. 3, -5. And when I put in 4, it came out as -8. You can see those kind of go in a straight line if my stylus was more fine than what it is. But you can just put points on each of those You can see mine kind of mess up there because I'm trying to get it to get the points on the graph. But it's real hard because my graph's so small. I think I said that 10 times, but okay. All right, now the next one. This is our last example. We can even have fractions. It doesn't matter. Our rule can have fractions in it. This rule is 1/4 x minus 1. So all I still do is I put in the -4 for x, because that's my input value. Do the math on the calculator, and my output's -2. 1/4 times 0 minus 1 is -1. 1/4 times 4 minus 1 is 0. 1/4 times 8 minus 1 is 1. And 1/4 times 12 minus 1 is 2. And again, here goes this little tiny, tiny graph. At -4, the output was 2. -2. For 0, the output was -1. For 4, the output was 0, so you're right on the x-axis. 8, 1. And you can notice my graph only goes to 10, so I can put a couple other marks to get to 12 too. So it'd be kind of off my graph that I have here, that last dot. But again, they make a line. You can see how they line up if I was to draw a line through it, which we're going to work on this next section. We're going to learn a whole lot more about this function called a line. But right now, I just wanted you to understand function rules and the inputs and outputs for that line. So you could see that all three were lines. We're going to talk about graphs on lines, and these are called linear equations. And that's going to be the focus of the rest of this unit.